recording. Okay, so far, what have I done? I haven't gotten around to grading your first assignment yet, but I should have some time tomorrow, so hopefully I'll get that done tomorrow. So you should have submitted 1A and 1B. I will get that turned around pretty quickly. The other thing is there should be a practice exam for you to practice the Respondus lockdown browser. So if you want to practice using the Respondus and what do they call it? The Respondus lockdown browser is the Respondus, and there's two different things that they call it. There's a lockdown browser, and then there's the attachment for the camera. So you have to have a webcam. Okay. What else did I need to go over? So the 10A video and the 10A notes are up. I will get the 10B video and the 10B notes up like pretty quickly after class. And so we went over the syllabus the first day. Then we went over 1A and 1B. We did that last Thursday. Today we're going over 1C and 1D. On Thursday we're going to change directions and we're going to go over some geometry, 10A and 10B. So we have 4 sections of logic and then 2 sections of geometry. And then we have a test. So today's Tuesday. Thursday, we're going to introduce 10A, 10B. Next Tuesday, we will go over the quiz. So I will be getting a quiz to y'all pretty soon. And then next Thursday is our exam. Are there any questions about like what's coming up, kind of what's expected?
So, we're going to be going over 1C and 1D today, and then next class will be 10A and 10B, and the test will be after that, correct?
Yeah. So we'll have 1 day of review too as well before.
Oh, okay.
Yeah. Which will be next Tuesday.
And since I was absent last class, and I have 1A and 1A and 1B, and y'all did the homework last class, where do I submit that?
So you should be able to submit it on the link in the Blackboard that says submitting written assignments.
Okay. Thank you.
Yep. Are there any questions over the stuff we've done 1A and 1B? So that was a bunch of truth tables and all that good stuff. We started introducing logic. I think 1A was all about the logical fallacies. So if you kind of have an understanding of what those sorts of things look like, I think it'd be I think most people do fairly well on that. I will try to lead you, so as long as you kind of have an idea of what the fallacy looks like, I think you should pretty much get it. So 1A was the logical fallacies. 1B, we started introducing truth tables, the connectors, the ands, ors, and if-then connectors. So you should be able to hopefully do a truth table of all those basic sort of things. And tell me the weird sort of thing with the if-then statement, right? I think that was probably the weirdest one. And so there's no questions over stuff we've done. I think I'm going to start getting into the stuff that we did today, or are doing today. So 1C, we started introducing Venn diagrams. So they taught us a few ways to draw Venn diagrams in 1C. Started talking about set theory, all that good stuff. And so that was chapter 1C. In 1D, we started analyzing arguments. So we're going to use those Venn diagrams to start analyzing arguments. So I think just jumping into what we got for this assignment, let me pin my screen and make sure this is focused nice and well. Okay, so I think the first few are pretty straightforward. And then I might try to break you off into groups and see if I can get y'all to talk to each other for a minute. Does it make sense? Decide whether each of the following statements makes sense or is clearly true or does not make sense or is clearly false. Explain your reasoning. The people who live in Chicago form a subset of those who rent apartments in Chicago.
No, it should be inverse. The people who rent apartments in Chicago are a subset of people who live in Chicago.
Yeah, so I'm thinking about everyone in Chicago and an apartment renter, just like a piece of that, right? So hopefully, like that's maybe the picture that's in your brain. Is like apartment renters should be a subset of all the people that live in Chicago, right? There's a bunch of different ways you could live in Chicago. You could own a house. You could rent an apartment. You could surf someone's couch. I don't know. But hopefully the picture that goes in your brain is something like this. Like the apartment renters are going to be a subset of all the people that live there. And the way that number 7 is asked is it's asking almost backwards, right? It's like, are the people who live in Chicago a subset of people that rent apartments in Chicago? No. And another way to think about that is if I take someone that lives in Chicago, are they going to also rent an apartment in Chicago?
Yes,
No.
that's what I said.
So if I take someone from Chicago, am I guaranteed that they're going to be renting an apartment in Chicago? There's no guarantee there, right? So that's another way you can tell that this is not a subset of this one, right? So if I take an element from this one, am I guaranteed that it's also going to be in this one, right? So if I take a person from Chicago, am I guaranteed that they're going to rent an apartment in Chicago? No.
So it's false?
Yeah, so this is false because it should be the other way around. The people who rent apartments in Chicago is a subset of the people who live in Chicago, not the way that they have it written.
All right.
Good explanation. 2-word explanation right there. Or is it one hyphenated word? I don't know. I don't know how that counts. So, number 9, I counted an irrational number of students in my stats class. Does that make any sense at all? Can we count an irrational number?
No, that does not make sense.
Yeah, it doesn't make any sense. Why doesn't it make sense?
Because how does she know which students are irrational? First of all.
Well, I mean, that's pretty easy to tell from my perspective usually, but I don't know from y'all's perspective. Yeah, so if you're counting, you're going to use the counting numbers, right? You're going to use whole numbers. If they're saying it's an irrational number, an irrational number is like a decimal that goes on and on forever. So you're telling me this is a decimal, right? Right there, you're giving me like it's a decimal amount of a student. So I don't know what your philosophy is, but I believe you count as a whole person. I believe each of you count as a whole person. And I believe for the most part, we're going to believe everyone counts as a whole person in this class. So this is...
So my reason is different than the reasoning you just gave, but because it's good that you gave that one so that I can understand it better. Because I'm looking at it as a face value of false and true, you know, like forensic theory. How do you know, why? So I don't know. Maybe I'm looking at this wrong.
So why did you say that you couldn't count an irrational number of students?
Huh?
So why did you say that this was false?
Because how does she know that the students that she counted are irrational?
So irrational is referring to what sort of number this is. It's not referring to the students, it's referring to the sort of number, the number set. And so I talked briefly about that, but irrational numbers are things that with like decimals that don't terminate. Things like pi and root 2, or just if you take a square root of any prime number, pretty much, you'll get an irrational number. Someone's coming up with something in the background. Okay.
I got it right though, but it's a different different reasoning than I thought.
Yeah, but you want to be careful with this word irrational because this isn't referring to the students, it's referring to the number that we're talking about.
Okay.
And so this is getting back at it. If we want to classify numbers, and I talked about this in the video briefly, like we start with the natural numbers, which is just like 1, 2, 3. We add 0 to get to the whole numbers. We add negative numbers to get to the integers. We add things that look like fractions, ratios, to get rational numbers. So you should be able to write a ratio. So these look like decimals that terminate or have like a repeating pattern. If it's not rational, it doesn't terminate or have a repeating pattern. We can't write it as a ratio. Real numbers are both rational and irrational numbers. They're going to include everything but imaginary numbers, right? Hey, chill. I got 2 rambunctious dogs right now. Okay. 888, I've eaten there a few times. But if we look at 888, 888, what sort of number is that? And we can kind of go this way, right? It is a real number. It's a rational number. So we want to keep on going till we get kind of to like the smallest set.
I put natural number.
It is going to be the smallest set. This is the basic sort of building block of numbers.
All right, I got that right.
That would be a natural number. That's something we can count to. Right? It's, the natural numbers are also known as your counting numbers. Sometimes, and it depends what book you're in. Like, I don't include 0 in my natural numbers. That's something that is completely up to like the mathematician. Like sometimes they will put 0 in. They're heathens. I don't know why they do that. Like 0 is a weird thing, and I really want to consider it separately, personally. But some people have weird ways of doing things. That was a little bit tangential, but let's look at 15. If I have 3/4, that is a real number. Is it a rational number?
Yes.
Yes. Is it an integer?
No.
No, it is not an integer. So this is going to be a rational number.
So far, so good.
It's a rational hashtag. No, it's a rational number. I feel like this guy's had an identity crisis throughout the last couple of decades. He's just like, is it a number, a hashtag, a pound sign? Who knows? And I've probably said this enough, but what is pi?
Pi would be a real number.
Yeah, it is a real number.
Yeah, that's what I said.
I would like go like directly, because this is what above that is numbers. And so to include the reals, we're going to tag on the irrationals with the irrationals, right? And so I would, if I wanted to be more specific, tell me it's an irrational number. It's kind of like the cliche example we give for an irrational number is like pi or root 2, right? Root 3 is also a good irrational.
Because the pi has a fractional equivalent.
It's got a fraction that never terminates, right?
Yeah.
And so that is where the irrational is.
Because if you break a pi down, it's 3.144, something like that.
Yeah, it keeps going and doesn't
It
repeat.
keeps going, yeah.
Yep.
So yeah, that's right. That's right. You got I did that wrong. I made it a real number. You got that
It is a real number, and that is the best thing that they give. That is the best descriptor on here that they give us. This is me going a little bit further than what they're asking.
But no, that's a good idea. It's valid. Let's say that. It's valid.
Now they want us to talk a few things about sets.
Ooh.
Well, as I use the set notation with braces to write the members of the following sets and state that the set has no members, use the 3 dots so we can use ellipses to indicate patterns. So if I want to talk about the dates of July, what do those things look like? I want to write a set. I'm going to start with what?
One.
First.
Yeah, you just write in the dates of July.
Okay, so how I did that is I kept going like you're doing, but then I added dots, and then I went 31. Is that all right?
This right here.
Ah, excellent.
Yeah, that's it exactly. That's what I would write. You could write out 31 different numbers if you really want to. If you feel like going for the gold, write out all 31 different numbers, but you can throw ellipses in there. They tell you can, so I think we can figure it out. So this is what the dates of July should look like. And so I think they're trying to get at something here, if I remember correctly. No, these are both numbers. Okay. So sets can be numbers, sets can be words, sets can be almost anything you want them to be, right? They can be categories. Okay. So that's 29. What is the next one? 33. Perfect squares between 10 and 40. So what they mean by perfect squares is things like 2 squared is 4, 3 squared is 9, squared would be 16, 5 squared would be 25. So perfect squares means it's the same number squared itself. So hopefully this is what you got in your brain when they say perfect squares. 4 and 9, 16, 25, 36, 49, 64. I think that's it, right? Between what, 10 and 40?
Hold on. So it's progressive. So when you get to 9, 16, where do you get this 6, 2 from?
So 2 times 2, 3 times 3, 4 times 4, 5 times 5. This is just the number
I
squared.
see. Okay, okay.
So I'm just going up 2, 3, 4, 5, 6, 7, 8, squaring each of those numbers.
Okay, I see.
So perfect squares is what we're looking at. And we want perfect squares between 10 and 40. Well, if I have them all written out like this, it's probably a bit easier. So I'm starting, where at 16, I believe. 25 and what, 36. 49 is already over 40, right? I think I have just 3 things. It should be those 3 numbers, I believe. And the questions over these sets. So these are both finite sets, right? But we could also have infinite sets. That's also a thing we can do. We can go off to infinity with our ellipses.
So, Professor, I didn't mean to cut you off right there, but
Yeah.
can you just tell me what the set that you acquired once we completed the?
Where, when, who, where?
Yeah, that.
This one?
Yes, the bottom here, the 16, 25, 36.
33. I also did not hear that one. I'm sorry.
So these are perfect squares between 10 and 40, right? And so I wrote out my perfect squares. Yeah, I wrote out my perfect squares, and I figured out which ones were between 10 and 40.
Oh.
Okay, thanks.
Yeah. And so the next thing, I think we're getting to writing Venn diagrams finally in this next problem. And so they give us 2 sort of examples here. Venn diagrams in 2 sets. And so I want you to think about this for a minute. One of them is teachers and women. That's 37. And 43 is teenagers and octogenarians. So octogenarians are people in their 80s. So I want you to think about how to draw the Venn diagrams for these sets. There were like 3 sort of ways we could draw things, I believe. Maybe there were more, but there are 3 off the top of my head I can remember. They can be disjoint, they can have an overlap, or they can be subsets, right? And so I want you to draw these. Think about how they're drawn. Go ahead and draw them. Okay, so if I'm drawing teachers and women, what should that Venn diagram look like? And I gave you those 3 sort of choices.
2 circles.
Yeah, and should it be, okay, so then are they overlapped, are they disjoint, or are they subsets?
Overlapped.
They are overlapped. And so let's think about this. Let's throw this out here. If I did subsets, I would have, what, like women that couldn't be teachers or something? All the women would be teachers, or all the teachers would be women. So I
Right.
think right off the bat, like hopefully we can reject the subsets, right? Not all women are teachers, and not all teachers are women.
All right.
Um,
So why did they go? Why are okay? So why are they not 2 separate circles?
okay, so if they were separate.
Yeah.
Are there teachers that are women?
Yes.
Yes, there are female teachers. That does exist. And so if we do this
Okay,
one,
but
there's no way to tell me that there are female teachers.
okay, but if the question doesn't say all teachers are women.
No.
Okay, so
But-
this is where I'm getting confused at, because when you say all teachers are women, then it's an overlap.
That would be a subset if it said all teachers are women.
Okay, excuse me. So okay, so let me see. Okay,
But it
so
doesn't
I
say
if
that. It
teachers-
just says,
if you're a teacher, that you know, if some teachers are women,
uh-huh.
how does that work like that? Some teachers are women?
Yeah, so so drawing in from what you know from reality, right?
Right.
We know that there are some teachers that are women.
Right. So that's
And
when
in
it
order-
overlaps.
In order to capture that, we have to have an overlap.
Right. But the question just says teachers and women.
Uh-huh.
It
So
doesn't
they
say
want-
some teachers are women.
Yeah, I know the question doesn't say that, but drawing in context from what you know about reality, right?
Okay. All right.
We
Okay.
know that some teachers can be women, or some women can be teachers.
Okay. I apologize. I'm just using a little bit different reasoning than you are, and it's my bad. It just feels that the question, if it says the teachers, some teachers are women, okay, yeah, we can overlap that. I mean, it's valid. But if I say teachers and women, I'm just adding another group. They have no relation.
So this is a set.
Isn't the square the Venn diagram?
Yes, so the
Venn-
square is the Venn diagram. This represents
Yes.
the universe
So
of
that's
everything.
all the elements of the question.
Yes. And so one of the sets is teachers and one of the sets is women.
It's women. That's it.
And so then we have to ask ourselves, is there an overlap of the set or are they disjoint?
Oh,
They are
okay.
obviously not subsets, right? Not all teachers are women and not all women are teachers. So that's
So we're
something that
rewriting it.
you can figure off the bat. It's not going to be a subset. The next thing we have to ask is, are they disjoint or are they overlapped? And so if we do them
They are
disjoint,
overlap.
there's no way to talk about women that are teachers. We want to be able to talk about women that are teachers because we know that there's an overlap in there and that exists.
So some
There are
teachers
women
are
teachers
women.
out there.
Yes.
So I think more the question you probably want to ask is, can there be an overlap, right?
Right. Okay.
Can we have someone that is both a woman and a teacher? And since you answer yes to that, you want to draw a picture that has an overlap.
All right.
On the other hand, if we look at this other thing, teenager and octogenarian, if you ask yourself the same question, right? Is there an overlap of teenagers and octogenarians? I think it's pretty easy to say they're not subsets of each other.
No.
Unless you got some weird Benjamin Button certain something like that. I don't know. But I hope you're right off the bat. You know that teenagers aren't subsets of octogenarians. Octogenarians aren't subsets of the other. So what should these Venn diagrams look like for teenagers and octogenarians? And I
Separate.
think
Separate.
they should be separate. And hopefully I led into that a
So
little
I
bit.
had. Okay.
So this
So-
one would be, yeah, disjoint sets, right?
Right. So I need to. So I need to look at all the variables involved with this when I do this. In other words, I need to say that can these be women or can teenagers be octagons to see if there's an overlap. Is that correct?
Yeah, so basically what you're asking is if there's some sort of overlap, can we have both of those qualities at the same time, right? Here, they can't be both teenagers and octogenarians. That's like a contradiction. So these definitely have to be disjoint. This was scratch work. That's not there anymore. This, they can be teachers and women at the same time. Those people exist. I've had a few of them for my teachers. And I think that's what they're trying to get at with this problem, right? They kind of give you one of each, one that's an overlap and one that's disjoint. Airliners and automobiles, I don't know. Are those like flying cars available yet? Right. No.
No.
Okay. I think we are on
I mean, they got them there.
one. So 61, I don't think I'm going to throw y'all into groups. I think I'm just going to make y'all do this. I'm going to give you like a few minutes, like 3 minutes to think these things through and hopefully pick off these numbers.
Can I ask a question regarding this Venn diagram?
Yeah, go ahead.
So regarding the I don't know that it's like pertinent to the problem, but regarding the total people at the party, like should I be looking at not only the amount of so the 22 men, would it also be 15 additional men that are under 30 and then 28 women? Or am I confusing the numbers? Does
Okay.
that question make sense?
If you want to know the number of men, you'd have to look inside the men's circle right here. So there'd be these two.
Right, so it would be 22 men plus 15 men that were under 30.
Uh-huh, yeah. And so these would be men over 30. These would be men under 30. This would be people that are not men, so female, I guess, women who are under 30.
Well, would that be women that are under 30, or is that circle people
Which
under
one?
30 and then
Which one is the
28
women under 30?
and then 28 is the amount of women?
Yeah, 28 is the women. Has to be.
So anything outside the men's circle, these two would both be women.
Okay,
Or they would not be men, I guess is probably more the problem.
okay. So I'm looking at all of these numbers are the total amount of people.
Yes, if you want to know the total amount of people, you would have to add everything.
Okay, got it. Thank you.
Can I ask another question on top of what she said?
Sure.
The 16, is that the women under 30?
Yep.
Oh, excellent. Right.
Wait, put that up here.
Mm. Nice question is, how do you pronounce your name? Elisnak? How do you pronounce your name?
My name's Lisa. It's
Oh,
Lisa
just-
Lesniak.
Oh,
Yeah. it's my
nice
last name.
question, Lisa.
Sorry, I just noticed they separated us into groups.
Huh?
I just noticed that he already separated us into groups, so I wasn't paying attention to.
Oh,
Oh, are we? I
No,
have no idea.
We're not in groups.
Oh,
No. Yeah, I'm being kind of lazy. The group thing is okay. It just takes a lot of time to kind of do, but it does I do like it because it gets y'all talking. And it gets the people that like are blank screen. I don't know, puts pressure on them to not be such a blank screen. So how many people are at the party are under 30? If we're looking at how many people are under 30, then give us a bubble for that. So we're looking at everything in this bubble. So what numbers did you put? What numbers are you adding there?
15, 16.
And 22, right?
Yeah. I put 15, 16.
Yeah, it should be
I
15
did
and 16.
Party under 30.
We're looking at this bubble of under 30, so it should be this 15 and the 16.
Oh, I thought it was the whole entire thing.
these are.
The 22 would be the men that are what, over 30? So men that are not under the age of 30 or men that are over 30, I guess is another way to say it. How many women at the party are not under 30? So if we want to look at women, horrible dichotomy, but what they're considering women are the people that are not men.
Yep.
So we
28. I just said 28. I don't know.
It's not going to be these two numbers because we know we're looking at women. And so if we want women not under 30, these would be women under 30. Yeah, and then I think you already said it, right? 28 would be the women who are over 30, right? Or not.
Excellent. Yeah.
So we're looking at those two numbers. It's got to be the 28 there. How many men are at the party? What numbers am I grabbing there?
22 and 15.
The
Yeah, I picked 22 and 15 too.
That blue circle, 22 and 15. And how many people are at the party?
81. I hope.
Yeah, that's it.
Okay.
And how'd you get that? You got that, Brian? I think you said it. So I know a lot of times when people do that thing with like how many people are there, they will completely like grab these three numbers, and usually this one's not center of the graph. Usually it's like way off over here. And so usually the one on the outside is the number that people will miss. So I don't know what to tell you on that besides word of caution, make sure you get that guy that's on the outside. You know, it's like here's our circles and we don't include him in there. Sometimes he's like way out here. But he's still there. Don't forget him. So that's 61. Oh man, I think we're almost done with this section. Now 63 and 65 I think are the last things. And then we got another worksheet. 63. So this is really annoying because it's
This
like
is crazy.
half on one page and half on another. But it's there. Here's people at a conference. Now we're doing a three-way Venn diagram, three circle. Use the Venn diagram to answer the following. So now they're looking at three factors. They're looking at whether they're women. So we'd have to add what, like 4 numbers if we look at inside this women's circle. We're looking at whether they have a college degree and whether they are employed. So these are people that are not women, don't have a college degree, and are not employed. So I'm hoping if I put my like pin in any like ones, hey, is it needed? No, sir. I'm hoping if I put my pin in any one spot, you can kind of tell me the properties that follow. I'm about to start a chain reaction, probably with the doggy barking.
Oh,
Okay, so
okay, so how many people
we have A, B.
are employed men? Employed right here.
Maybe I can get it on here.
Wait,
C and D right there.
men is 3.
So I'm gonna give you all about 5 to do this. It shouldn't take any longer, hopefully.
College degree.
Employed men. I got it all on there. I think that's it.
So, 13. 4. 6. 24. 4. 24. I got that right. College degree. It becomes all employed women without a college degree. 8. That's all of them. No, it's not. Right, that's right. So valid.
Yeah, and I don't think we're gonna get much more than 3 bubbles, but you could probably imagine like these Venn diagrams can get pretty complicated pretty quick, depending upon how many sets you want to talk about. Okay.
Stop rubbing your dry ass.
Just because you said it.
All right. So how many people at the conference are employed men with a college degree? Okay, so employed is telling us it should be in this white circle. Men is telling us it should not be in this blue circle, so it's got to be in the white circle, not in the blue circle. And then the last thing they say, they have a college degree, so it should also be in that red circle. So what is that first number that you should look at?
16.
It is that 16 right there. It's got to be in both of them, but not in the blue. So that is, I don't know, that's like, can we like read what this spot right here means, basically, I think. How many people at the conference are unemployed women? So we're not in the employment, so not in the white.
Would it be
You cut out right there at the end. You said, would it be? And then that's all I heard.
Would it be 24?
It would be 24. So they're not employed, but they are women, so they have to be in that blue circle. So that is the 20 and the 4. We're going to add them together and get 4.
I have a question. Like on the other ones that you added like the 2, like okay, for like A, we added the other ones. Why wouldn't we add like 9 and 16 and then 16? Like we added the other one. Correct.
For part A, they give us like 3 stipulations. For this one, they're only giving us 2. So it like remains that we have to add a few together. But if we're looking at this one, they're not women. They have to be in both of these at the same time. They have to be both college degrees.
But it can't be all 3.
11? Is that what you're saying? Yeah, it
No,
can't
I'm
be.
just asking like 9 plus 6 plus 16.
Okay, because if we went here, these would be college degree men, but they're not employed. So it has to be in both
Oh,
of these.
okay.
And it has to be in both of these at the same time, right?
I'm with you.
It's got to be in the overlap of these 2.
Okay.
So it's got to be in the overlap of these 2, but not in this one.
So that's where I was confused at. 16 isn't just an isolated number.
Yeah, it is. It is isolated in here and one of those spots.
So what happened to 9 and 6?
9 and 6, we're not considering it in that one because they're asking for people who are employed. And if we grab the 9, these people aren't employed. And they're asking for people that have a college degree. And if we grab the 6, these people do not have that college degree. They want something in the overlap of the red and the white, but not in the blue.
Right. Okay, so can I ask a question? Who are the employed men?
Employed men
That would be like
people
6.
not in the blue, but in the white. So the 6 and 16, these are employed men, but these don't have a college degree. We want the ones with a college degree.
No, I understand that. No, it says how many people are employed men of
With a
college
college
degree. So 16 is the employed men.
With a college degree.
No, 16 is in the men category, right? Because the women category, okay, I understand now.
Yes,
No, I get it now.
This is men, this
Yes.
is men. Anything outside the women is going to be men.
Right, I got it. Yes, I got it. Okay.
So how many people at the conference are employed women without a college degree?
I said 8.
Yeah, so we're looking here. We know they're employed women, so we know it should be the overlap of these 2 circles, the white and the blue. And so it should either be 8 or 11. And then the next thing we read is they don't have a college degree.
Yeah.
So we want the one that's not in the red. Should be this one out here. Should be the A. How many women are at the conference?
$43.
Yeah, how'd you get that? How many numbers are you adding?
I counted all of the numbers included in the blue. So
Yeah.
8, 4, 11, and 20.
We're doing 428 and 11. We add those together, should give us 43. The women are the one in the blue circle. What if they wanted employed women? What if they asked that? I know they didn't ask that. Where would you look at for employed women? My connection's unstable, so who knows if you'll see me for. I might be cutting in and out. I don't know. But if we wanted employed women, where would we look?
They would have to be white and blue, right?
Yeah, that's it. So if we look at between the white and the blue.
19.
Yeah, you're doing the 8 plus 11 to get to the 19. So that's what that gap would look like, right? And if we want employed women with a college degree, which one would that be?
How many women did what?
Employed women with a college degree.
31.
So if I want it to have this, I want them to be women, I want them to have a college degree, and I want them to be employed. How many people fit that description?
Employed women.
11.
11, right? 11 people have all three of those qualities at the same time.
Employed women.
And I'm seeing that from the center of the circle. That's the overlap of all three of those things. Okay. So I'm hoping you should be able to pick numbers off of a Venn diagram like this, and you should understand like what set it belongs to.
Also, it's 11.
Okay, so that is 63. We have one more in this section. Uh, 65, they want us to create a Venn diagram from a table. So the following numbers of patients in a hypothetical hospital on a single day, we're taking A is antibiotics, BP is blood pressure, and P stands for pain medication. And they give us all these numbers. So the first thing we want to do is create a 3-circle Venn diagram. Yeah, it's part A. That summarizes the results in this table. So it says they can take all 3 medicines. So I'm hoping when you draw your Venn diagram, it looks something like this. Maybe a little prettier. Maybe you're a better artist than I am. But you have your 3-circle Venn diagram. And what do I want to label these circles?
A, P, and BP.
Okay. So we're looking at this. We see A only is 12. And if they're only taking A,
BP is 8.
these are the people that are only taking A. They're not taking blood pressure. They're not taking pain medicine, right? And so if they're only taking A, we want it just in A, not in anything else. If we want A and BP only, so they're doing A and BP only, this should be in the overlap of A and BP. So if I'm looking, I have this is my entire overlap, but that word only means they want it
15.
right here, right? Without the pain medicine.
Hey,
It should go in that little spot right there.
I did it right.
If we want
All right.
BP only, now we're doing BP only. It should be in the BP circle and in no other circle.
8. So,
And now we want to go A and P. So now we go A and P. And I think I mentioned it, but when we say and, it looks like this symbol. When we do intersection, ooh, that's the symbol we use for intersection. So these things look very much alike. And then the other thing that like kind of correlates is the or in the union symbol. So if we're saying it's in this set and in this set, we're saying it's in the intersection of sets, right? So when we talk about members, I think we typically use the word and. When we talk about the sets, we're talking about the intersection. Or if we want a member from this set or that set, what we're doing is we're unionizing the sets. We're bringing the set, adding the sets together. So those concepts kind of correlate with each other. So if you
I
see,
need to be familiarized with the symbol you just gave us.
no, I mean, but it might pop up in your life some point.
Oh wow. Okay.
A and P only. So A and P only says 24. So A and P means the intersection of A and P, but only this intersection. We don't want the overlap of all three of them, right?
That's right.
And the next thing is P only. If you want to do P only, that means in the circle of P,
20. P only is.
and then no other circle. So that is the 22 right there. BP and P only is 16. So that is this overlap.
Wait a minute. Did you just say P? Wait, hold up. Did you just say P only is 22?
P only is 22.
Okay. All right.
BP and P only is 16.
Right. That's right.
None of them are 2. So where does none go?
In the
Two is at the
universe.
side.
In the universe, it's inside the universe, but outside of the circles. And the last one, all 3 medications are 20. You could probably figure out where this number goes. There's only one other spot left there. That is the one where they are taking all 3 of them in the middle of the overlap of all 3 of them.
All right.
So this should be something hopefully you could do. I know in the notes we did a 2-circle Venn diagram, a 2-set Venn diagram. This has a few more numbers. So I think a 2-set has what, 4 numbers? This has what, 8 numbers? So each time you're going to double the amount of numbers you have. So like I said, we typically aren't going to go for 3 sets. So this is part A. So part A says to draw the Venn diagram. How many patients took pain medication or blood pressure medicine? So pain or blood pressure.
30.
Oh, let me get this back. He's done it back.
Well, so the wording of that is a little vague to
30.
me.
Okay, so they want to know who took pain medicine or blood pressure medicine. So
But do
this,
they mean, sorry to interrupt, but do they mean only pain or only blood pressure? Or do they mean all of the people that took?
yes. So when we use the word or and in math and in logic in general, like we mean the inclusive. So they can take pain medicine, they can take blood pressure medicine, or we can include the people that are in the overlap there.
So then our total is much larger than 30, correct?
Yes, it's going to be a
Okay.
big total.
Thank
Okay, so
So if you're thinking it's a big number, you're probably correct.
46.
And this is what, like I was kind of saying, when you use or, you're building like a larger set. You're putting these two things together, kind of.
Would it be 105?
Yeah, that's it. Okay. So this is pain or blood pressure. So if we're looking at pain medicine, that's 22 people there, that's 24 people there, that's 20 people there, and that's 16 people. So that takes account of everyone that's in my pain medicine category. And I still have to add people that took blood pressure but didn't take pain, right? So this is what, 15 and 8 that I'm adding? And if you add all these numbers, I believe these should give you 105. And so this is sort of like that or that unionizing. We're taking this set of things and we're taking this set of things and we're creating this big or set right here. And so we're looking at everything that is in P and everything that is in BP.
82. Is that 82?
Do they ask it in a good way that gets at that concept? How many patients took blood pressure but not antibiotics?
So did you just do number did you just do E?
That was part B.
Huh?
That was part B. How many patients took pain medicine or blood pressure medicine?
Oh.
And so if we look at part C, how many patients took blood pressure medication but not antibiotics? So we are in blood pressure. So blood pressure but not antibiotics.
So 8, 16, 20, 15.
46.
8 and what number? So it's blood pressure.
Not 15.
8
Not
plus 16?
correct.
Yeah, so it should be this 8 and the 16. So we're in blood pressure, but not in the A circle. So that should be the 8 and the 16. What is that, 24? 24, right? Can I do simple algebra, simple arithmetic now?
I had that right. All right. All right.
So that is in what? Blood pressure, not antibiotics. And that is what? C. Part D. How many patients took at least blood pressure medication? So at least blood pressure medicine. So if they say at least blood pressure, this would be only blood pressure, right? Would be the 8. So if they say at least blood pressure, what do they mean?
Plus 15, plus 20, plus 16.
Yeah, we got to add everything in the circle that has blood pressure. Exactly. Yep. 8 plus 15 plus 20 plus 16.
Oh,
You have to show the dog at the end of class. It's a rule.
second that.
I think that one's my dog that's barking right now, actually.
Well, now you have to as well.
Yeah. Okay, so we have these four numbers. I think someone already said it was what? If we add those four, they should give us 59. And so that is part D. How many patients took at least blood pressure medication? E says how many patients took only pain medicine? Oh, that one's easy. So the people taking only pain medicine would be which number? They give it right there on your thing too. That's straight from the graph they give you, or the chart they give you, huh?
22.
The 22. Yeah. You scared me for a second with that pause. Okay, so yeah, 22. That's people taking only pain medicine. How many patients took exactly 2 medications? That's an interesting question. So what numbers are those?
55.
Yeah, what numbers are you grabbing though? I think that's probably the better way to get it.
The 16, the 24, and the 15.
Yeah, the 16, the 24, and the 15. These are people taking 3 medicines. These would be the people taking 2 medicines. These would be the people taking 1 medicines. These would be the people taking none way over here, these 2, right? So the 2 medicines would be the overlap of 2 sets, but not the overlap of 3 sets. This is another way to think about it. 15, 16, 24, plus 16, plus 24.
I'm confused.
And what did you say that again? 15, 16, 24 is what, 55?
Yes.
Why is it not just 20 though?
What?
20, this would be the people that take all 3 medicines. And so the question says, how many patients took exactly 2 medicines?
Oh,
That's
okay.
right.
I am done. Okay.
Yeah, you got it. You just got to like read the, make sure you read the question right?
Right.
Yeah. Okay, so I know we did this and we kind of went over it, but if we went like P or B or P or BP, there's actually something we kind of skimmed over, and I will go over it. So everything that's in P, take everything that's in BP. This was going back to like question part B, right? If we wanted people that took pain medicine or took blood pressure, we were adding up everything that's in here. We were adding up everything that's in here. So if you were to add up everything that's in P and you were to add up everything that's in BP, you might notice that you ended up counting something twice if you did that. And so there is this sort of issue, like we're going to end up counting those twice if we just add P and we add BP. And so sometimes you might see this, but if we're adding 2 variables, we have to subtract their intersection. So this was something like when we did that Boolean algebra, it like popped up once. This sort of thing popped up when we're talking about OR statements. And so if we're adding 2 things that have an overlap, when we add them up, we're going to end up counting that overlap twice. And so we only want that overlap once. So we're going to have to end up subtracting the overlap. So that might be something to look out for in the future if that pops up in a problem, which it might. Or it may not. I don't know if it does or not. But it is a thing that happens, right? So it's worth talking about. So I think that's it from, was that the final one? Yeah, that 65 was the final one on there. The next thing I want to go over, were there any questions over the Venn diagrams? I want to spend a good amount of time on this logic worksheet. So a lot of this first half, this part should be, excuse me, sort of a review.
Oh, I was going to ask real quick, where do we get the logic worksheet? I know.
So the logic worksheet, I put it up on Blackboard.
Yeah.
Should say something along the lines of like logic exercises or something.
Oh, okay, cool.
It's
Thanks.
in there somewhere, yeah.
Awesome.
And I know I put it up pretty early this morning, so I kind of put it up last minute, to be honest. It wasn't up till like this morning. But it's up there, and your homework's not due till tomorrow, so hopefully you'll have some time.
All right.
If you can print this thing off, print it off. If not, make sure you do some neat work at least, right? Make your work a little neat, a little bit of gradable.
You want
Have a
us,
few people
like,
to grade.
you want us like redo the paper if we can't print it? I can't personally print.
Yeah, if you can't print, just make sure you don't have to like copy down everything. Just copy down the stuff where you're filling in the blanks mostly, right? So if we look at this, all flamingos have feathers. So we want to rephrase this into an if-then statement. So how do we rephrase all flamingos have feathers into an if-then statement?
If flamingos, then feathers.
Yeah, so if it is a flamingo, right? Flamingo, then it has feathers. So I'm hoping you write your if-then statement. So like if you don't have this worksheet, write down the if-then statement, draw off the Venn diagram for it. So what does my Venn diagram for an if-then statement look like?
One circle inside a smaller circle.
Yeah, it is a subset.
Yep.
It should look like a subset. And so hopefully you're writing some kind of word to represent these things. I should go my P or my flamingo. On the outside should go the feathers. And so this is the sort of structure of an if-then statement. You're making a statement sort of about subsets. So this is the subset of this one. And you might notice, like, is this true in reality? If it's a flamingo, then it has feathers. Unless you pick a weird featherless flamingo out there, like this is a statement that holds true, right? There might be an exception to the rule, but this is the general rule. If you're a flamingo, you are a feather-bearing creature. This hopefully makes sense. Is this saying the same thing? All feathered creatures are flamingos? Is that true?
No, it's
No.
not true.
No, that one's not true. They are
That's not.
So if I want to rewrite this as an if-then statement, ignore the fact that this round box is here. It's not supposed to be here. I don't know why it got put there. Just formatting issues. So all feathered creatures are flamingos. So this is saying if it is a what?
If it is feathered, then it's a flamingo.
Feathered. Then it is a flamingo. And I think we talked a little bit about this. I'm not really expecting you to like memorize these things so much, but this is swapping them. And if you're swapping things, it's sort of like a con is going on. There's some sort of swap. There's some sort of con happening. This is the converse. So this would be the converse statement of this original thing. And it does look like a subset. That looking thing. He looks really excited right now. Or does it look different? So what's my smaller set in this one?
Feathered creatures.
Yeah, so feathers is going to go on the inside now. It's not the same statement. It's not logically equivalent. So hopefully you're not drawing the same picture. How many of these we got? 4? I'll do like 3 of them. I think that's pretty good. Okay. And you can thank Miss Shram if you love this. And if you want to be mad at someone, you can be mad at Miss Shram if you don't like it. How about that? We'll just let her take all the responsibility of this worksheet. She's the one that made it. If you have a ticket, then you can get into C up. Okay, so this one is already in an if-then statement. I guess there's not a lot of much thinking on how to write this thing. If you have a ticket, then you can see up. If not, you're gonna have to look down. Okay, so if this is a statement, it is an if-then statement, so I know this might be revolutionary, but how do we draw if-then statements? I'll give you a hint. They should all look the same. No, this thing should look like a subset. I know it's a lot of times over and over again. But all these are if-then statements. They should all kind of look the same. They should all have a subset, right? And now we want to put in some words to represent these sets.
Yeah.
So the smaller set here would be what?
Ticket.
This would be having your ticket. And if you have your ticket, then you can go see up.
Mm-hmm.
And you probably figured out this statement.
If I get into C up, then you had a ticket.
Same thing, but now we're flipping these things. And so
Yeah.
if we flip our P's and our Q's, we're also going to flip these sets. And so what I think they're trying to get you used to doing on these first 4 is to write if-then statements. If P, then Q, and in general, like I know it's not on here, here's my little bit right here. I usually always go in if then Q, right? Q. So my P usually goes on the inside, my Q usually goes on the outside, as long as I'm doing if P, then Q. This is the structure I'm hoping you can get down. You're going to use this structure to verify the validity of arguments in a minute, right? If you don't get up, you got to get down, I guess, right?
No.
Yeah, I don't want to do this one. I don't like these. To be honest, I don't like this vocabulary. Yeah, I'm going to skip this one. I was going to cut a few out. I'm going to cut one more out. Why not? I don't like that necessary and sufficient. It's okay. Y'all can figure it out if you want. But eating your Wheaties will make you strong. If you are strong, then you have eaten your Wheaties. This, I think, I'm going to let you do this one on your own. I've already done 2 of them. I want you to do this one. And so you should be able to do that for homework. It's not too much. You could probably do it right now before I even turn to the other paper, if you've been paying attention and you're astute enough.
And you want us to turn that part in or no?
Yeah. Finish it up for homework.
Oh, that is the paper. That's the actual paper.
Yeah.
Okay. That was like an example paper or something.
So if you have an iguana, then you have a reptile. Oh, your picture should look like the same, like we've been doing. So iguana on the inside, reptile on the outside. And now we want to talk about the converse, inverse, and contrapositive. So we want to be able to write these things. And I believe we started talking about these like towards the end of 1B, but I like kind of barely sort of touched on them. But if we want the converse, this is like we're swapping things. So this I want to reverse these things. So if you have, and what am I going to say first now?
Reptile.
Yeah, that's it. If you have a reptile, then I'm going to insert some words because I'm in a math class. Then it's a lizard, right? Then you have a lizard. The inverse is when we start throwing knots in there. We keep them in the same order, but we throw knots. If you don't have one, then it's not a lizard. Wait, just say that. Reptile. Ah.
Hmm.
If it's not an iguana, then it's not a reptile. There we go. I'm changing things around, but I keep things around. Sorry. So maybe I should write it over here. If Q, then P. And this one is if not P, then not Q. And the contrapositive is the final one. So this one we flip things, this one we negate things. This one we're going to do both. We're going to flip things and we negate things. So if we do not have, if not Q, then not P is what this was what the contrapositive looked like, right? And so if we go not Q, not a reptile.
Oh man, so okay. So can I ask a question?
Uh-huh.
The converse. Now the converse is similar to the statement, but it's broken down because we're going Q then P, right?
Yeah, we're going if Q then P. And so let's
okay, so all I said was if iguana, then you have a reptile.
Is that true? If it's an iguana, then it's a reptile. This one is true, right? The original statement. If you have a reptile, then it's an iguana. Is that true? That may not be true. There's other things that are reptiles that aren't iguanas.
That are iguana.
Yeah, so this is
so
not
I put
true.
that in the wrong area. So the converse is to switch.
Yes.
Okay, all right. Well, I put that in the wrong area.
And so what you might notice is that this one holds true, this one doesn't hold true, this one doesn't hold true. But guess what? This one holds true. And so I talked about this briefly in the notes, but the original and the contrapositive, these two things are logically equivalent. And these two things are logically equivalent.
So aside from, it says that we need to make Venn diagrams for each of these, aside from flipping like the reptile and the iguana, would negating it change the Venn diagram at all, or do we just relabel it as like not reptile?
That's one of those weird things is you can kind of do them either way. So whether I do a set that's called iguana, right? If I do a set that's called iguana, these are things that are iguanas, these are things that aren't iguanas.
Uh-huh.
But you can also do a set that's called not iguana, right?
Right.
And it captures the same idea that you have things that are both not and things that are iguanas. And it's kind of, you're writing the Venn diagram from an inverse perspective. I don't know. And part of that is I don't want you to do the Venn diagrams for these. That's why they used to be over here and I cut them off.
Oh, okay.
So like, don't sketch the Venn diagram for each. Just like rewrite the phrase.
Got it.
I'm more interested in just the original Venn diagram and the phrases.
Okay.
Okay, so I will do. I'm gonna skip the Aggies one. I'm gonna let y'all do that one for homework. Let's do.
Which one?
Too controversial.
Oh, okay.
Yeah, too controversial, I guess.
Yeah, that one was crazy. I wish you would do that one.
I'll do two of them. I need to
Okay.
figure out the third. I feel like if I'm just doing everything for you, then you're not getting nothing. So if x is an integer, then the square root of 13 is an integer.
Okay. Okay, Professor. Before you start, I think I missed something. On the contrapositive, you told us to do that one for homework for the reptile and the iguana.
The reptile, so if it's not a reptile, then it's not an iguana. That was the contrapositive there.
Okay, I got it right. All right.
The conditional here is if x is an integer, then square root of 13 is an integer. So this is if x is an integer. We're saying square root of 13 is an integer.
I got that right.
So the converse says if, and what am I going to start with?
X is not
Square of 13.
So I'm flipping them. So I'm going if square root
It's
of
not.
13 is integer. Then what?
X is your integer.
Yeah, then x is integer. And the inverse looks like what? If not this, then not that, right? So if x is not an integer, then root 13 is also not an integer. So it stays in the same order. We just throw the knots in there. And the last thing, the contrapositive, we have to swap and we have to throw knots in there. So if not this, so if square root of 13 is not an integer, then x is not an integer. And so I think this might be a good example to talk about it on. So in a minute, we're going to get to analyzing validity of arguments. And so if they tell us something like if you have an iguana, then you have a reptile. And then they're going to do something like confirming this first part, right? You have an iguana. What can you tell me then? You can tell me that you have a reptile, right? That would be a conclusion you can draw. So if we know this if-then statement and we can confirm that P is true, that kind of forces this other thing to also have to be true if this entire statement's true. And we went through like a truth table of if-then statements. But if this if-then statement's true and if P is true, then it's forced, right? It's kind of forced that this other thing is true. You can also do if I flick the switch, the light will come on. If that's a true statement, and if I flick the switch, then you can guarantee the light's going to come on, right? And so that's one sort of structure the validity arguments can have. So a valid argument can have this, where we assume P, we're going to follow through with the Q, right? The other sort of valid argument follows the contrapositive. That's the other one we can also look at. So if we know it's not a reptile, then it's not an iguana, right? So if we don't have a reptile, then we don't have an iguana. That's a true statement. So if they tell us this, and they tell us it's not a reptile, then guess what we can conclude? We can conclude this thing. It's not an iguana, right? So those are the two sorts of forms that they can have. And I believe one of them is what? Confirming the hypothesis. And one of them is denying the consequence, right? I believe is what they're labeled or something. I don't remember those forms. I don't memorize forms. My advice is going to be to draw them Venn diagrams, and the Venn diagram will tell you. With that said, we want to get at a few of these. Spend a little bit of time with these. All pigeons are messy. We want to write that as an if-then statement. So if it is what, then it is what?
If it's a pigeon, then it's messy.
Pigeon. Then it's, and so P would be what?
P for pigeon.
It is pigeon. It's messy. So I want to like maybe step back. Look at the things that are in bold here, right? This is their premise, this is their premise, this is the conclusion. They're given for a premise, and this is what they're saying the conclusion is. Everything else is just stuff that we need to fill in about that premise or that conclusion that's going to get you to the structure of this thing. Whew. So Tweety Pie is a pigeon. Is that a P statement or is that a Q statement?
P.
That is P, and it is saying that Tweety Pie is a pigeon. That is saying that P is true. Tweety Pie is a pigeon. You're telling me P is true. If you're telling me Tweety Pie is not a pigeon, that would mean our P was false, right? Okay, so we have these two things. We want to draw these two things. So this first thing, if it is a pigeon, then it is messy. This is the if-then statement. We've done a lot of if-then statements. So I'm hoping you know how to draw your if-then statements by
So can I ask a question?
Yes.
Tweety Pie is a pigeon. So we just take it face value. We don't add, we don't try to
So I'm not even looking at
like question it, right?
I'm not even looking at this right now. I'm just looking at all pigeons are messy.
Yeah,
Okay.
got that right.
And now they say Tweety Pie is a pigeon. There is something maybe I should say, like this is a universal statement, right? If I say all pigeons are messy, I'm talking about the sets of things. This thing is actually telling me something exists. So this is an existential statement. So we do say things like that. This is universal. So universal statements tell me things about the sets. Existential statements are going to tell me something about members, right? So Tweety Pie is a pigeon. This is telling me to put an X somewhere in here. Where is this telling me to put my X?
Inside pigeon.
Inside the pigeon, yes. Figuratively, not literally on that one, right? Okay, so put your X inside the circle that says pigeon. Therefore, Tweety Pie is messy. So Tweety Pie is messy. The conclusion is saying, what is it saying? It's making a messy statement. Are they saying Q is true or are they saying Q is false? It is saying it is true. It is true that he is messy. Or she. I don't remember Tweety Pie's gender. I don't even know Tweety Pie had a gender, to be honest. Okay. Is this a valid argument?
Yes.
Yes. You're saying it's valid. And let's check, like, why is this valid? So if we put our X with Tweety Pie being a pigeon, is it also guaranteed that Tweety Pie is going to be messy?
Yes.
By this picture, it is absolutely guaranteed. There's no way you're going to put an X in pigeon without making it also within the messy circle. So this is valid logic.
So I see you didn't do it, so that's good. Because I was wondering, what do I say for Q? But you didn't mark anything, so I did that right, I guess.
So Q is it's messy.
Okay.
So if they say Tweety Pie is messy, what they're saying is that it is true. Q is true. If they say Tweety Pie is not messy, then they would be saying Q is false.
Right. But it's only one statement for all of those. That's where I was getting at.
So we're saying Tweety Pie is messy. That's telling me Q is true.
All right, that's good.
Okay. All integers are real numbers. Minus 42 is an integer. Therefore, minus 42 is a real number. So I didn't ask for it. Maybe it's a little weird. This one's a little weird because we're talking about Tweety Pie, right? And Tweety Pie is not real. I could also ask you for soundness, right? This has a lot of opinionated things like messy in it. So this may not be a good example to talk about soundness. It's kind of a silly example. But this one, I could absolutely ask you about soundness on, right? All integers are real numbers. So if what, then what? So if
Integers.
real, right? And so P is going to be
Integers.
real. We want to draw the Venn diagram in the box below. So I guess we go ahead and start drawing. I did the previous one in. But this would be my integer. This would be my real. So that should be this first premise. All integers are real numbers should look something like this Venn diagram.
That's right. So that
The next thing we see is minus 42 is an integer. Is that a P statement or a Q statement? Are they saying something about integers or reals? They're saying something about integers. So what are they saying?
that is minus 42 an integer.
So minus 42 is an integer. Is that saying P is true or P is false?
P is false. I see it false. I don't know.
Is true.
This is saying P is true. It's saying it is an integer. P is saying it is an integer. So if this is confirming P, it's going to be true.
Okay.
So we are confirming what we're saying in our P statement. And if we know it is an integer, we want to put an X to represent minus 42 being an integer. We're going to put our X in the circle that says
Oh, that's what I did.
integer.
Never mind.
And so now we're looking at this conclusion. Therefore, minus 42 is a real number.
Yes.
So that is saying
The conclusion is false.
the conclusion is saying
That Q is true.
Q is true. It is saying that it is a real number.
Valid statement.
And this is a valid statement. If we put an X inside the smaller circle, it is guaranteed to be inside the bigger circle.
Oh.
How many more do I got? Get that one. Yeah, let's do it. Okay. Is this sound? So is valid. If it's invalid, I can't even ask you if it's sound, right? If it's invalid, it's definitely not sound. You can just reject the soundness right away. But validity means it fits the structure, right? Soundness means we're taking into reality. So I want to ask maybe an extra little question here. Is this sound? Is it true that all integers are real numbers? Is this a true statement?
Yes.
Yes, that's true. Is minus 42 an integer?
Yes.
Yes, that's true. Is minus 42 also a real number?
I'm gonna have to say yes.
Yeah. Well, in general, if these two are true and you're using valid logic, this one should also hold true, right? Okay. But if you have true premises and you're doing valid logic, this whole thing is sound. This is a sound argument. We can have things that are valid and not sound. We'll probably have one like that in a minute. Okay, so all integers are real numbers. It's the same thing we had in the previous problem. So, yeah. Same setup from the previous one. But now they're giving us a different premise for our second premise. Root 5 is not an integer. So P says things about integers, Q says things about reals. So if they're talking about integers, they're making a P statement.
That P is not true.
They're saying P is not true. Another way to say not true is false. There we go. P is false. We finally get one that says it's false. We've had a bunch of them saying they're all true. Therefore, I'll draw my diagram in a minute. I know I'm slacking on it. Therefore, square root of 5 is not a real number. So it's going to be one of these statements.
It's a Q statement,
It's saying
and it would be false.
And it's saying it's not real. Q is saying it is real. If it says it's not real, then we're calling Q false. And I'm not going to talk about validity until I draw my diagram, but I have my integer. I have my real bubble outside of that. I want to put my X on here. 4 square root of 5 is not an integer. So what is this line telling me? I look at my integer bubble and it tells me I cannot go inside my integer bubble. It's not an integer. I'm not in here. So where am I? Can it go here?
On the border of real?
Yeah, and so this was a sort of thing in the notes. It can go here. It can go here. It can go either way. I don't know whether it's inside or not that bubble. So I'm going to put it on the border. And their conclusion is saying square root of 5 is not a real number. Can I conclude that it's not going to go in the real circle?
No.
No. And so this is not valid.
So you didn't put it outside the circle, you put it on the line of
On
the
the
real?
border, yep. So I don't know whether it goes inside or outside. There's no way to tell.
So, okay.
So I just put it on the border. It could go either way.
All right.
And so since it can go either way, I can't reject that it's inside of here, right? And so since I can't reject that it's inside of here, this is not a valid conclusion.
All right.
And so if it's not valid, it's not sound, so I can't even ask you too much more on that. Okay. And so I think we got like, this is one sort of way it could look valid, right? We say if P then Q, and I give you P, that guarantees Q is going to be true, right? So if it is an integer, then it is real. This number is an integer. We can conclude that it is also going to be real. And so this is the straightforward, I think this is the most straightforward if then valid logical argument. This is confirming the hypothesis, I believe is what they call it, something like that. Basically, we're going to say our first statement's true, and it's going to follow our second statement also has to be true. And so if you think about just the original statement, I think that one will maybe help you. This one, all integers are real numbers, so I think this is exactly the same thing we had. If it is real. And I think we're right at time, so if you need to go somewhere, you can go ahead and go somewhere. But I will continue recording and going through a few more examples.
I have a question before I go, Professor.
Yeah.
Thursday, I had to leave a little early because I had to get to work on time. But I wanted to know with the lectures and everything that you're posting, are we to expect a lecture to be posted after each and every class so we can do this work?
I'm confused by what you mean by the lecture. The classes will get posted after the class. Is that what you're talking about?
No, I just
Or the lesson plans, like the 1A, 1B?
Exactly, the lesson plan, yes, sir.
So typically I will have the lesson plans before class. I know I'm a little bit behind on those. I don't have the 10B up quite yet. I will get the 10B up pretty quick today after class. But 10A is definitely up there. So I'm hoping you go and you complete this homework and you complete this logic worksheet. By the time you do this logic worksheet and get through 10A, I will probably have 10B up there for y'all, hopefully.
Okay, thank you.
And then the other thing that y'all should check out is that practice test, right? Get used to the Respondus lockdown browser and the crazy stuff that it makes you do. And I think, I feel like there's one other thing that I put up for y'all, but I can't remember. The quizzes will be up soon. I don't have the quiz on there yet, so don't try to do the quiz. It's not on there, but it will be on there as soon as I get it up. So back to this problem. If it's an integer, then it is real. P is going to be it is an integer. Q is going to be it is real. If we say 7i is not a real number, now we're changing things around a little bit from what we did previously. So this says 7i is not real. What sort of statement is this making?
Oh, contradicted. It's saying
A
it
Q
is real.
statement.
It's making a Q statement. Is it calling Q true or false?
False.
It is saying Q is false. So Q says it is real. This is saying it is not real. So this means that Q is going to be false. And so we want to write integer. We want to write real. Now I want to put my X to represent that 7i. Oh man, I hear Pelote Man outside somewhere, jingling some bells. 7i is not a real number. So I want to put an X, and I want to put it not in the real circle. Where does that go?
Or
He's got to go outside that real. Okay, so if he's going outside the real, and we say 7i is not an integer is the next statement. Seven I is saying something about integers. So it's got to be P. Is it saying P is false or P is true?
P is false.
P is false is what this thing is telling me. Is this a valid or an invalid argument? So if it's not real, does that also guarantee that it's not going to be an integer?
Only integers are real in this case, so yes.
Yes. So if we're on the outside of the real, it is guaranteed by like the subset thing that it is also going to be outside that integer box or circle.
Oh shit.
And this is the other valid form of an argument. So one of them was what? Affirming the hypothesis, right? So if we affirm their hypothesis, we get our conclusion. The other thing we can do is we can deny this conclusion. This comes back. Right? If we look at the contrapositive, this is basically, we're doing the same thing with the contrapositive. We're saying if not Q, then not P. And we're going to not Q. We're going to get not P out of that then. So it's the same sort of structure that we made a valid argument with the original statement, but we're using the same sort of structure. This is one way to think about it, right? And there are multiple ways we can think about it. And like I said, I don't expect you to maybe memorize this structure as much as I expect you to be able to do these Venn diagrams.
Would this be considered sound?
There you go.
This is valid. This would be a sound argument because all these things are true, I believe. This is true. 7i is an imaginary number. It's not real. And since it's imaginary, not real, it's definitely not an integer. So this would also be sound. Yep. And I think this might be the last form that we can have with arguments. So this thing looks like all integers are real numbers. We want to rewrite this. So this is the same thing over again. I'm being really lazy. This is saying the same thing over again and over again. So if it is not an integer, what is this saying?
P is false.
This is giving me P is false. Not real. Would be what? Q is false. This is integer. Real.
I did.
And now I want to test this thing for validity. If I know it's not an integer, where am I putting my X?
Inside real numbers?
It could go inside real numbers. Does it go inside integers?
No.
It does not go inside integers. It could go here. Can it go over here?
It could.
It could go here. It could go here. So where am I putting it?
Oh, jeez.
You got to put it on the border. We don't know where it goes. It could go either one. We got to put it in both, right? You got to put it on the border. So is this argument valid or invalid? Can we conclude that it is not a real number based on this diagram?
No.
No.
No. We cannot conclude it's not a real number. This would be invalid.
Got that right.
And so I'm getting this right because it's invalid. It cannot be sound.
Yeah. We're not. The second we say invalid, you know it's not sound. Because part of sound is that it has to be both valid and true. Yep. Okay, so we got a few more. What do we got? 1, 2, 4. All right, I want to go through like 2 more of these, and then I think I'll leave like 2 of them for you to do on your own. Would be fair enough. All accordion players belong in jail.
I agree.
Yeah, it play accordion. In jail, right? So P would be about playing accordion. P would be jail. Or you belong in jail. There ain't something about jail. And so if Willie does not play accordion, that's my P statement, is playing accordion. He doesn't do this, saying is false. So P is false.
All right. I did that. Oh my God.
Accordion, so if an accordion, then jail. The accordion should be my subset of the jail. If Willie does not play accordion, where am I putting my X for Willie?
I put the X on the outside.
So can it go inside here?
No.
Cannot go inside here. Can it go here?
No.
Maybe.
Maybe. Can it go here?
Yes.
Yeah. So it could go here or here. Where am I going to put it?
On the line.
On the border, right there.
So can I ask? So this is when the reasoning comes in. This is when you say, "Can this happen?" Right?
Yep.
Okay. Because you don't do it for the other part, but you do it for this part.
So this gives you the Venn diagram itself, right? This gives you the sets in the Venn diagram. This will give you the X to put there. This is the existential thing that tells you someone exists here. And he exists not in the accordions. So we don't know whether it goes in jail or not. So we put it on the border. The conclusion says Willie.
But we know he doesn't because they say all accordions belong in jail.
So all accordion players belong in jail. Willie does not
play accordion.
So he might belong in jail, or he may not belong in jail. There's other things you can do to put yourself in jail besides playing accordion.
Okay.
And then it says, therefore, Willie doesn't belong in jail. Can we conclude that from this picture?
No,
we can't.
Because you're saying that he's in jail.
Nope. So that's invalid. And then I guess the other thing is Willie doesn't belong in jail. That is a not Q statement, or Q is false is what it's saying, right? And one more for the road. It is necessary for a man to play the bagpipes in order to wear a kilt.
If he plays bagpipes, then he wears a kilt.
Is that what it's saying? This one always kind of confuses me, this wording, to be honest. That's I don't like the necessary and sufficient ones, to be honest.
It's weird.
It is necessary for a man to play the bagpipes in order to wear a kilt.
So bagpipes are the prerequisite to wearing a kilt?
Yeah, is necessary. Yeah, so if you wear, I think it's like if you wear a kilt, then you must play. Is that what it's saying? If you wear a kilt, then you must. I don't know. I don't like this one. Are they? Is there? Yeah, I don't want to do this one. Y'all don't have to do this one for homework either. If y'all skip that one, I won't count it off.
Oh.
Thanks.
I really just like hate that wording. Like it messes me up, and if it messes me up, I'm obviously not gonna put it on my test, right?
We appreciate it.
Yeah. So eating hot fudge sundaes causes insanity. This one I think is fair and it's straightforward. If you
eat a sundae,
would be eat Sunday. It would mean that you go insane. So if Patty is insane, what is that saying?
that cue is true.
Okay, so let's draw a little Venn diagram and test for validity. So this would be the Sundays. This would be going insane. And Patty is insane. Where are we going to put this X? So it has to go inside the insane bubble. But I guess my question is, does it go inside or outside the sundae? Can we tell?
We have to put the X on the line until we read the conclusion.
Yeah, we have to put it on the line. We don't know whether it goes inside the sundae or not. We know it goes inside the insane. That's all they give us. So we don't know if it goes inside here or not. We have to put it on the border. The conclusion is, therefore, she eats hot fudge sundaes. So that sounds like what? P is true?
Mm-hmm.
And is this a valid argument? Do we know whether she's inside the sundae or not?
No.
No. Yeah. So in general, and there might be a weird way that I could word these, but if you're putting things on a border, that's probably a pretty good indication that you can't really draw conclusions about it, right?
Yeah.
Yeah.
I think I'm starting to get the hang of this.
Okay. It's just asking whether you can put it inside the circle or not. Like what circle you need to put your X in. Okay, so I guess I saved you one. All flamingos and feathers and Donald Duck and stuff. So I'm going to stop the recording.